Proteins are very important for the human being because it will provide the growth as well as it maintains the development in the living organism. The primary structure means each amino acid they bind together to form a sequence, and between the amino acid there will be a linkage that is known as peptide linkage. Remember, this denaturation of protein, it is very important for the examination point of view, and it can be asked for 2 marks. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Biomolecules. Under that, we have discussed about the polysaccharides. In that, we have discussed about the cellulose and glycogen, and also we have talked about the importance of carbohydrates, and we have discussed that what are amino acids, classification of amino acids, and important 20 different amino acids also we have learned. In addition to that, the important concept called as Zwitter ion formation in the amino acids also we have learned. Today let us move on to the next topic of this unit about the protein. So what is a protein? What are the classification of the protein? What is the structure of the protein? We are going to understand in this session. In addition to that, what is denaturation of the protein and enzymes we are going to understand in this session. Let's see what are protein. We know that proteins are the building blocks of our body. Is it right? They are the macromolecules which mainly help us to grow and maintain the good health. So, hence the proteins are also known as the building blocks of our body. So, the proteins are the polymers of alpha amino acids, and they are connected together by a peptide bond or by peptide linkage. The peptide bonds are more than 100 amino acid residues which are having the molecular mass which is higher than 10,000, hence it is also known as protein. So, proteins are very important for the human being because it will provide the growth as well as it maintains the development in the living organism. And there are of 2 types of protein. The first one is fibrous protein and another one is globular protein. We can classify this protein into 2 types only based on the shape. So, based upon the shape, based upon the molecular shape, we can classify the proteins into 2 types. They are the fibrous protein and non-fibrous, which is also known as globular protein. Again, this differences, it is very important for the 2 marks. They will ask you to write the differences between fibrous and non-fibrous or the globular protein. What is fibrous protein? We know that we have understood that between the protein there will be a peptide bond. So in the fibrous protein, these are the protein which forms a thread-like structure, and between the amino acid there will be a peptide bond. In addition to this, the bond which is also gets supported with a hydrogen and a disulfide bond. It is also gets supported by hydrogen and a disulfide bond. And remember, such kind of proteins which looks like a thread or with the fibers. Hence, it is named as fibrous protein. The best example is keratin, which is present in our hair. So, that is why our hairs and the nails which grow very lengthy because of the presence of fibrous protein. Okay. And the myosin which is present in the muscle, which is another example for the fibrous protein. And remember, this kind of the proteins are generally insoluble in water. They are insoluble in water. Coming into the globular protein, these are the protein. They are formed from the amino acid and they had a peptide linkage in it. When they forms a peptide linkage, these proteins are folded themselves to form a spherical shape. To form a spherical shape. Hence, it is named as globular protein. And this kind of proteins are always soluble in water. The best example is insulin and albumin. So we know that insulin will be produced from the pancreas. Is it right? So it will maintain the blood sugar level. So this protein, which is the best example for the globular protein, because it will easily mix with water, or we can say that it is soluble in water. Next is, we'll understand what are the structure of protein. We can clearly understand the structure of protein into the different stages. The first one is the primary step, or you can say that it is a primary structure. Next is secondary structure. Third one is tertiary structure, and fourth one is quaternary structure. Let's see, in the primary structure, how does this amino acid are linked together by a peptide bond, and why it is known as primary structure and secondary and tertiary and quaternary? Let us understand now. I'll go with the primary structure first. The primary structures of the protein are refers to the specific sequence on which various amino acids are present in it, and the sequence of linkages between the amino acids in a peptide chain. If the sequence changes, the nature of protein is also get changed. Here you can see that this is a one amino acid, this is another amino acid. Like this, each amino acid, they link together to form a sequence of chain. This sequence of chain, which is formed by the amino acid by forming what? Peptide bond. By forming what? Peptide bond. By forming peptide bond, they arrange in a sequence. Suppose if any one of the amino acid is missed, or if it is changed, the nature of this protein which also get changed. Hence, this is known as primary structure of protein. Remember, the primary structure means each amino acid, they bind together to form a sequence, and between the amino acid there will be a linkage that is known as peptide linkage or peptide bond. When it comes to the secondary, it refers to the shape in which long peptide chain can exit. This structure will be resulted due to the regular folding of a long peptide chain, and these foldings are caused due to the hydrogen bonding between the one hydrogen atom of the NH group and oxygen atom of the another group of the different amide. Some of the different polypeptide chains can possible here. I have represented the two structures of this. One is alpha helical structure, another one is beta helical structure. You can see that in the beta plated sheet, and there is a one alpha plated sheet. You can see that these alpha helicals are just, they coil around each other. This is a primary structure, and this primary structure, they just coil around themselves and forms a secondary structure. And in each folding, you can see that there will be a formation of hydrogen bond. You can see that at the each edges, there will be a formation of hydrogen bond. Where does it exist? Between the one NH and between the another CO molecule. NH and CO, there will be a hydrogen bonding will be exits. So just they coil around themselves to form a alpha helix. Similarly, when these primary structure, they just folded themselves in the form of sheet. Then we say it as beta plated sheet, and this will be looks like a sheet only, where you can see that this is a structure or the sequence of the amino acid, and between these, you can see that there will be a hydrogen bonding which is exist. So just they are arranged themselves in the form of sheet, where in the alpha helix they just folded themselves to form a helical structure. This is said to be secondary structure of protein. Then comes to the tertiary structure. It refers to the overall folding of a polypeptide chain. The further foldings of secondary structure are of two types, which give rise to the fibrous protein and globular protein. So you can see that this is an entire representation of the polypeptide chain, where you can see that each amino acid, they folded themselves to form a secondary structure, and altogether secondary structures are said to be tertiary structure, which is the overall representation of the polypeptide chain. And in this case, you can see that there is a two different forms of proteins will be there. That is, fibrous protein can exist, or it will be exists in the globular structure. Then comes to in secondary structure, we know that between each amino acid, there will be one hydrogen bond. But when these overall, if you represent the polypeptide chain in the form of tertiary structure, there will be additional support for this bond also. That is mainly because of the hydrogen bonding, disulfide linkage, van der Waals forces and electrostatic forces. In addition to the polypeptide chain, there will be a hydrogen bonding, disulfide linkage, and van der Waals force will be there, and electrostatic force will be there. So altogether will be forms a tertiary structure in the protein. When it comes to the quaternary structure, some of the proteins are composed of two or more polypeptide chain. They are known as subunits. Here you can see that this is a one subunit and this is another subunit. So each polypeptides may be different. When they fold it themselves, it forms to the quaternary structure. So this is one more another polypeptide, and this is another one polypeptides. Like this, each polypeptide, when they comes together, they forms a quaternary structure. So this is how we can understand the structure of protein from the primary to quaternary. So hope you all understood with this structure. We'll move on to the denaturation of protein. We all know that proteins are the biomolecules and it will perform a specific biological function in our body. Is it right? If the protein which perform a specific biological function in our body, it will have its own activity. Is it right? Such class of proteins are said to be native protein. If you disturb this native protein, either by changing their physical state, such as by increasing the temperature, either by changing their chemical nature, just by increasing the pH or by altering the pH, you can say. Then what will happen? The nature of the protein will be get disturbed and leads into the formation of denaturation of protein. The best example is, in your home, you would have seen that the coagulation of the egg with the white and curdling of milk is the best example. And you would have seen that in your home, once they prepare the non-veg, they won't keep for the next day. Why is it so? Because we know that the meat are very rich in protein. When you keep for the next day, and if you cook and if you eat once again, the protein structure will be get altered. That is why when you eat the non-veg today, the freshly prepared one, if you eat it tomorrow, their taste will become different because of the protein which is undergoing denaturation, where you are going to alter the physical state as well as with the chemical change you are going to apply on it and causes a disturbance in their structure. This causes a denaturation of protein. So, we'll see what is a native protein once again. The protein which is found in a biological system which having its own unique three-dimensional structure, and the biological activity will be also known as native protein. Then what is the denaturation of protein? The loss of biological activity of a protein when a protein is it in the native form, when it is subjected to the physical change such as changing in temperature or by changing in chemical factors such as pH, so that it undergo denaturation of protein. Example is coagulation of egg white on boiling and curdling of milk are the best example for this denaturation. Remember, this denaturation of protein, it is very important for the examination point of view, and it can be asked for 2 marks. Okay, it can be asked for 2 marks and they'll ask you to write what is a denaturation of protein. So, hope you understood with the denaturation of protein. Now, let us see what are enzymes. So we have understood that what is a protein, what are the different types of protein, structure of the protein. If the protein structures get disturbed, how does it forms a denaturation in their activity also we have understood. We are going for the next topic of this unit, that is enzymes. Already we have learned that what are enzymes. Is it right? Yes. So enzymes are the protein, and these enzymes are also known as biological catalyst because it will catalyze a specific type of reactions in our body. Hence, enzymes are also known as biological catalyst. And we all already understood that enzymes are very specific to the substrate. Is it right? Because each enzyme will have their active site where the substance will go and binds to that and forms an intermediate product where that intermediate product will be itself give rise to the product. Correct? No? Yes. But when these enzymes, when it is react with the substrate, whatever the product which is formed, we will name this enzyme based on which it works with the substrate. The best example is the conversion of maltoses into glucoses. During this process, I have used a maltase as an enzyme, where the maltase is an enzyme which is acting on the maltoses, hence the name will be given as maltase. This is another important thing we must know about the enzyme. If the enzymes are reacting with the substrate, in such cases, we will give the names of that enzyme by taking the substrate name, and always while naming the enzyme, we should use ACE. We will use what? ACE. So this is another condition we must learn about the enzyme. So when it is act on the substrate, we will consider that substrate name, and for that we will add the ACE, so it will become maltase. We have understood that how the enzyme will be binds with the substrate by forming an enzyme substrate complex in the surface chemistry. So you watch that video to understand that more about the how enzyme will be involved with lock and key theory model to form a product. So you will understand that. So please watch that video to understand more about the mechanism of enzyme catalyst. So by this, I like to say that in the next session, we are going to start with the hormones and the types of hormones. So at last, I like to say that, so what are all the different concepts which I have learned, especially the denaturation, types of protein, fibrous proteins and globular proteins, which is a very important concept for your board exam. Have a look on it and try to make a note. We'll meet you in the next session. Till that, take care, be safe. Thank you.